Hey everybody. So in today's lesson, I'm going to be talking to you about what it means to have global extrema, local extrema, and more importantly, critical points. Okay. So the definition of a critical point is this. It's where the derivative of the function equals zero or where the derivative of the function is undefined. So basically we're going to be looking at graphs and we want to be seeing what is happening at certain critical points. And the whole goal behind this is that we want to be applying derivatives, but in order to apply derivatives to certain real life problems, we have to understand how the function that is describing these real world situations actually works. So I'm going to go over a few examples on how we can find a critical point. So here's a typical question. So let's say that you have f of x equals 2x cubed minus 9x squared plus 12x. And we want to know, all right, well, where are these critical points? So we know the critical points exist when the derivative is either equal to zero or the derivative is undefined. Now, so let's go ahead and do that. So I'm going to go ahead and copy down my function. So let's do it on a separate board. So we've got f of x equals 2x cubed minus 9x squared plus 12x. All right, sorry about that. I was just copying that down. So here we go. There's our function. So we want to find our critical points. So what we do is we take the derivative of that function. So using the power rule, we're going to get 6x squared minus 18x plus 12. Okay, there we go. Now the first check is, are there any points on this derivative that are undefined? Like, are there any values of x that we can't plug in, values of x that won't work? And in this case, nothing. You can use every single value of x here, so therefore there's no points that are undefined. So now what we're going to do is we're going to set f prime of x equal to 0. Excuse me. So that will give me 0 equals 6x squared minus 18x plus 12. And then we're going to solve that. So divide everything by 6. You'll get x squared minus 3x plus 2. And then I'm going to go ahead and factor this. So for this one, I'm going to get 2 parentheses with an x at the beginning of each one. And my two numbers that multiply to make 2 and add together to make -3 are -2 and -1. So if I set these two factors equal to 0, I get x minus 2 equals 0, x minus 1 equals 0. So therefore, I've got x equals 2, and I've got x equals 1. So those two values of x will make the entire function of the derivative equal 0. So 2 and 1 are my critical points. So critical values or critical points exist at x equals 2 and x equals 1. Now let's have a look at that graphically. All right, so I put on here a graph of that function. So if you look at this, that point right there, that's the point where x equals 1, and this point is where x equals 2. Now, critical points often occur when you have what we call a local maximum or a local minimum. So a local maximum is somewhere within the curve where you kind of reach a peak, and a local minimum is somewhere where within the curve you reach a minimum. Now, a global minimum and a global maximum would be the highest possible or the lowest possible values. So in this case, the global maximum, well, it wouldn't exist because it goes up to infinity, and a global minimum wouldn't exist because it goes down to -infinity. All right, let's have a look at another example. Okay, so let's have a look at this one right here. So we have f of x equals x plus 1 over x minus 3. And we want to see if there's any critical points for this. So again, the first thing I want to do is take my derivative. So for this, we're going to have to use the quotient rule. So the derivative of x plus 1 is just 1, and then I multiply it by x minus 3, minus, leave the top, and then multiply by the derivative of the bottom, which is just 1. And that's going to be all over the denominator squared. All right, so let's go ahead and tidy this up. 1 multiplied by x minus 3 is x minus 3. 1 multiplied by x plus 1 is x plus 1. But be careful to keep that inside parentheses. And then that's all over x minus 3 squared. So if I go ahead and I simplify that, x minus x will cancel. Negative 3 minus 1 will give me negative 4. So this gives me this function. So remember, we're trying to see, are there any values where the derivative equals 0? And are there any values for where the function is undefined? So undefined basically means you can't take the square root of a negative and you can't divide by a 0. So if I look at this, if I set x minus 3 equal to 0, because x minus 3 can't be 0 because then I'm dividing by 0, that means it looks like I'm going to have a critical point at x equals 3. Okay. Now, if I set this equal to 0, I'll get 0 equals negative 4 over x minus 3 squared. Now, if I tried to solve that, I would have to multiply both sides by x minus 3 squared, which would give me 0 equals negative 4. And that doesn't make any sense. So therefore, there's only one critical value, and that is at x equals 3. So let's have a look at what that looks like on a graph. So let me just go ahead and undo that one and put this one back on. So if I zoom out a little bit here, you can see that the critical value here exists at this vertical asymptote. So you basically have this chasm where x equals 3. So even though it's not like a minimum or a maximum, it's still essential to look at because something very interesting is happening at that point of x equals 3. Therefore, it's known as a critical value. All right, so you're going to get some practice at this today. If you have any questions, please just reach out to me and let me know. Thanks very much.